Hey, thank you to be here. I'm Nathan. You probably realize that today data, content, media grow significantly. We are consuming more and more of them. For large companies specialized in media and entertainment, distributing this content, those media is a big challenge, especially for post-production teams. When it comes to moderate the content, generate metadata, or comply to country-specific laws, and even more at a large scale. So up to now, for most of the companies, moderating, analyzing video content to curate unwanted segments was really tedious, time-consuming, painful, since it was done for most of them manually. So let's have a look at this file. As you can see here, this is an XML file containing items symbolized as markers uh, of a reviewed media before it goes to a post-production team for editing purposes. It means that we have somebody watching the entire video and looking to flag unwanted items and put it all these items inside this XML file. So as you can think, it's really time consuming and painful for the end user to do that kind of processing manually. So the question is, how can we build a pipeline to automate this process and export metadata that post-production teams can use in their editing software using AWS Media Intelligence Services and AI/ML services such as AWS Recognition and AWS Transcribe. Before building the pipeline, it was time for architecturing the project, the pipeline, the services that we will take advantage of. So we ask ourselves, on top of which framework, ecosystem, service will we build this pipeline? The first option that came to our mind was media to cloud. Media to cloud is a highly scalable, elastic, and secure solution that that is using cloud services that customers more easily ingest, store, process, deliver, and manage content in the cloud. The problem is that this cheap solution is hard to customize because of internal dependencies. There are a lot of nested CloudFormation stacks that depends on other CloudFormation stacks. So we simply decided to switch the Amplify services. So I don't know if anyone here have ever heard of Amplify ecosystem or know or AWS Amplify, but to to stay quite simple, AWS Amplify provides a full set of tools to build secure, scalable, full stack applications, and to be more precise, full stack mobile applications powered by AWS. So you can easily add authentication, data, or AI ML services to your application and so on using this ecosystem. Amplify also provides a CLI giving ability to automatically configure your cloud backend and just connect this backend to your application and let you just accelerate development for common workflows, for instance, authentication, sign in, sign up. Another cool service from Amplify is Amplify Console, a fully managed hosting service that serves content from Amazon Content Delivery Network. It has built-in workflow for CI/CD that accelerate development. All you have to do is just connect your repository and all the changes are deployed automatically. So it's a really cool feature. One last thing about AWS Amplify is that it supports multiple environment workflow that matches the standard Git workflow. So multiple developers on a team can also share and manipulate the environment together. AWS Amplify, in addition to supporting built-in plugins such as authentication, storage, REST, or GraphQL API, we can also use community libraries. And since we are working with media assets, including video, we are obliged to use Amplify Video plugin, an open source plugin for the Amplify CLI that makes it easier to incorporate video streaming, video on demand into mobile and web applications. So what's really interesting with Amplify Video is that it's never been easier to produce and distribute video. And just by answering a few prompts in the command line, Amplify Video will spin up infrastructure that adheres to best practices codified by the AWS community. So we decided to take advantage of Amplify video on demand capabilities to give post-production team ability to see what they are reviewing using the pipeline we built on the web application provided with our solution. So to summarize, before going through the demo of our web application on the pipeline, Amplify is a big ecosystem with a powerful set of services, tools, libraries that allows to quickly set up a full stack project, both for web application or mobile applications. So Amplify brings together best practices codified by the AWS community, is completely adapted to team projects. So if you don't have any question, maybe we can move on the demo and see what we built using all this cool stuff. Okay, I think you can now see my screen. So we are on the web application that we built using the AML services from AWS and the Amplify ecosystem. So we have a really simple sign-in screen using AWS Cognito with a user pool. We are using the React front-end library framework to take advantage of the existing UI component, just to save time during the development. So I already have an account on the portal, so I will log myself in. But you can customize this login screen with your own components, add MFA features, human verification during the sign up and the signing process. You can do a lot of cool things. I will let you check the documentation to see what are the limits of this service. So I will click sign in. I will be redirect on our dashboard. It's loading. So here, here appears all the video that we ingested inside the specific bucket. When we ingest a new video, the video asset will appear here with a pending status. The status will be updated depending of the recognition, analyze running on it, and the transcript generation. So once all the AML services analysis will be done, the status will change for ready for review. So once a video is ready for review, we will have the number of markers that have been detected by the different AML services. So just to clarify, a marker is an item that has been detected by those services. We would have the number of reviewed items, so the reviewed markers on the notes, because you can also add notes to a reviewed marker. So we click on a video. On the left side, we have the event list. The event list is basically the markers that have been detected by the services. On the right side, we have the playback. We have a video player with the playback video. So this is provided by the Amplify video on demand service. So it will allow the end user to see what is reviewing. So for instance, if we look at specific marker here, let's move. So maybe here, it will automatically switch the timeline of the video player at the right position for the specific marker. Here we can choose to validate the marker. So if we want to keep the item for the editing process, or if we want to drop it. So here I will accept. And we can also leave a note. So for instance, if I add a specific note here, so this marker is correct, it will appear in our exported files for the post-production team for the editing purposes. So here I have the possibility to export the markers. We also are able to generate an EDL file. This is an edit decision list. We're also able to generate all the markers or only the kept markers file. So the XML file that we generate can be imported inside editing software. So for instance, Final Cut Pro or Adobe Premiere. And I will show you what we can do with that. So I will download all the marker in the XML format. This is a specific format that can be interpreted by the editing software. So for the demo purpose, I already have some files, replace it. I will switch on Adobe Premiere. So I downloaded my XML file. This has a specific schema, a specific skeleton to be understood by Adobe Premiere. So I will import this file in Adobe Premiere. Here we can see that we have a new sequence. It's looking for a missing file, so I will locate the file. And basically the file which Adobe Premiere is looking for is the file that we ingested inside our pipeline. So you can have a proxy on a remote server, what you want. We'll just import the file here. So here it is. Okay. So now that I imported the missing file, I will click on my sequence. And if I look here on the timeline, we have different markers. So the we decided to put the content markers, so detected by recognition content moderation service, as red markers, and the blue one are the transcribe markers for the unwanted words detected by our vocabulary filter. So here in the markers tab, we can see all the all the items that have been detected by the AWS services and that have been extracted, transformed by our pipeline to be understood by Adobe Premiere. So click on this one, it will search automatically on the timeline at the right position. So at the end, the post-production team will be able to cut or blur some specific segments of the video. So we can see here how we take advantage of the AI/ML services and media intelligence services to make post-production team life easier when editing long content instead of having all this reviewing process being done manually. So here it is. I think if you don't have question, I can go back to my presentation support. So here is the architecture diagram of the pipeline and the web application I showed you previously. So we basically have our clients that will drop a video media set for reviewing purposes. So we have an input bucket that is generated by the Amplify video plugin, thanks to the AWS Amplify CLI for handling all the infrastructure provisioning. Once a video is dropped inside this bucket, it will trigger an AWS Lambda that will be in charge to start various jobs. So recognition with the content moderation API. We also have the segment API, segment detection API to generate edit decision list. As I showed you on the front end. This is the EDL file. We also have the transcribe service that will analyze that will generate a transcript file and look for unwanted words based on a vocabulary filter that we created before our demo. And to finish on the jobs, we have Media Convert that will be in charge to take our initial file, create a proxy file of it, generate MP3 file for transcribe service, and it will also generate an HLS playlist, so we can have the playback video on the front-end application. All those services will run asynchronously. So once done, they will trigger some events through SNS and CloudWatch. All those events will be pushed inside an SQS queue, while Lambda will wait to process the new messages. And we after that, we took advantage of the Amplify API plugin. So we set up an AppSync API. So all the we can take advantage of all the directives. So we don't have to create the DynamoDB tables. Everything is managed by Amplify. And will pass through the AppSync API. So it will generate tables and create directly new records from the Lambda that process the SQS messages. On each new insert, we will generate the markers and the EGL file, and we are also able to trigger them directly from the front end with custom resolvers that we added to our AppSync API. So all the front end is hosted using Amplify console, as you can see here. So we have our static content working with the different Amplify library, and all of them are served through the Amazon CloudFront CDN. And the authentication is managed by AWS Kernel. So this is basically a kind of very soft media to cloud that we can easily customize thanks to the Amplify CLI and all the different plugins that it offers. So I think we saw everything concerning the architecture. So feel free to ask your question and we will be glad to answer your questions. Thanks for listening.